Hello, everyone. Today we're going to share how the French Ministry of Education is developing and implementing PCIs to redefine assessment for more authentic context. So please feel free to drop any questions that you might have directly into the webinar chat, and we hope to answer them at the end of the session. And now it's my pleasure to introduce today's speakers. We have Mark Oswald, the co-founder and CEO of Open Assessment Technologies, a Luxembourg software company leading innovation in assessment technology. Mark is a vocal proponent of interoperability through industry standards, serving as the first chairman of the IMS Global Executive Board on Assessment. Prior to IMS Global, Mark served on the boards of the Storage Networking Industry Association and the Fibre Channel Industry Association, from which he received a Lifetime Achievement Award for his work on solutions interoperability. We're also joined by Saskia Kespiak from DEPP, of the Assessment, Forecasting and Performance Directorate of the Ministry of Education of France. Saskia is the project manager for technology enhanced items and other assessment related tools and applications development, and also plays a key role in coordination of the Flip Plus development group, the Flip Plus e-assessment community. So now it's my pleasure to turn over the presentation to our speakers to get started, and I will hand it over to Mark.
All right, thank you, Sam, and welcome everybody to our session here. So I'm going to share spend a few minutes here explaining a little bit what we do as an organization and the value that we bring to the market. And then after me, after about 5 minutes, I will hand over to Saskia, who's going to show you in quite a bit of detail the amazing and innovative work they're doing at the French Ministry of Education. So first of all, our company, OAT, Open Assessment Technologies, it's the home of TAO. You may know TAO. It's the one and only open source solution that is available to education customers to run assessment at scale. And when we discuss that with our customers, we always begin by explaining how it fits in, how they should look at assessment and TAO. And a big part of conveying that understanding is that it's all about enterprise class. And often we get a reaction like, why enterprise class? Where in Ministry of Education, can you explain? And you know, once you start looking into it, it quickly becomes very clear that when you develop or when you deliver assessments, let's say to 3 million students, well, 3 million students, that makes 6 million parents, probably makes 500,000 of teachers. You add the unions and politicians, and very quickly you can see the level exposure that you have within a country or a state. And so that's why this digital transformation, that's why we approach it with an enterprise mindset, because the solution really needs to be deeply embedded into existing systems that capture everything from student rostering, national or state level, student databases, deep analysis and reporting. So there are many components that need to come together here. And the way we provide these solutions, the two major pillars are, of course, open source for the assessment components that we make available, and open standards. And this, of course, enables not just because when you hear about open source, it's, you know, you think open source community, but it goes actually a bit of a step further. And I just want to spend a minute here explaining, if we go to the next slide, the Flip Plus organization, which is because with open source, you really enable an economy of sharing. And Flip Plus, if you haven't heard about the organization yet, it's meanwhile it started at 4 countries, France, Luxembourg, Italy, and Portugal. They were all users of TAO, the open source platform at that time, and they've come together to not just collaborate on the technology level, but take it a few steps further. And today the organization is over 20 member organizations, so not just departments of education in Europe, but we also have representatives from Japan, in the United States. For instance, we have UNESCO that is a member, and it goes beyond pure technology sharing. So sharing of best practices, which came in as a really great asset to the members here, as everybody was struggling to adjust to the pandemic over a year ago. And then, of course, also sharing of content. And so there's quite a significant item library that's available to member organizations. And so if you are an organizational education organization, I would strongly recommend that you look into this organization, and because there's tremendous benefits that can be gained from this. And so now going to the next slide, so quickly here, there are many considerations, of course, as you go through this digital transformation and rolling out digital assessments. And a really crucial one, of course, is standards compliance and interoperability, because without that, you just live in a silo without much opportunity to get additional value add by combining data and by analyzing not just a slice of the picture, but the entire picture. And one of the key standards, of course, for us, and what we're going to talk about today, is QTI. So if we go to the next slide, QTI, which I'm sure you're all familiar with, and in particular the portable custom interactions. And what I really like about PCIs is that it's basically the future built into the standards, which is a very difficult thing to pull off. Because by implementing PCIs, you can really model, advance any type of interaction into your item. And so that it's this technology that allows you to build authentic assessments or task-based assessments by reproducing classroom activities, measuring 21st century skills such as coding or team collaboration. And it really leads to deep insights as to how students absorb the learning material and how they apply it to solve specific problems. And so it's with this that I'm going to hand over to my colleague here from the French Ministry of Education, Saskia, who's going to give you a lot more information about the cool work that they're doing. Thank you.
And thanks a lot, Mark, and thank you, Samantha, for the introduction. So before presenting you the PCIs that we've been developing in France and the insights that we've gained from the use of this type of items, I would just like to present broadly the Ministry of Education in France, and also the assessment, the student assessment system that has been put in place. So with the more than 1 million employees, the French Ministry of Education is the largest employer in France. And it's a quite centralized system that is organized as 30 academies or regional entities. And we have around 13 million students in K-12 and enrolled in many schools, and especially we have many schools at the elementary level. And there are many student assessment programs, standardized student assessment programs that we are running at the DEPP. So next slide, please. So the DEPP is the Department of Statistics and Evaluation of the Ministry of Education. And these assessment programs can be regrouped largely in 3-year blocks. So first we have the National Sample-Based Service, which can be subject-based, or they can also be cross-curricular. We have longitudinal programs, and we also have assessment programs for policy evaluation. And then we have the equivalent sample-based programs for international comparison. So DEPP is responsible for conducting in France international surveys such as PISA, PIRLS, TIMSS, and more recently ICILS and ICCS. And then during the past 4 or 5 years, we've set up nationwide assessments that are usually happening at the beginning of the school year and at certain grade levels. At these grade levels, all students, so that represents around 800,000 students in France per grade level, are taking a standardized assessment. And these assessments have two main objectives. So first, it is enabling us to identify students that are struggling, so students who have learning difficulties. And this is why these assessments are happening at the beginning of the school year, so we can diagnostic the students very early and remedy for their difficulties. And then, of course, these assessments also allow us to provide indicators at every level of the education system. So from classroom through regional level to the national level. And next slide, please. In conducting this census-based assessment has become possible also because since 2015, we've been transitioning from paper-based assessments to digital assessments. So in our case, these are either computer-based or tablet-based assessments. And of course, besides the scalability, this transition has brought along other new opportunities, such as cost reduction, also the possibility to add new features in our assessments, more interactivity, to enhance accessibility, and also to make our assessments more fun for students, hence increasing their motivation to take these tests that do not have direct consequences to their school progression. And of course, we can also obtain very rich data from these assessments. A digital mode allows us to collect very, very rich data. And I will come back to this a little bit later. Nevertheless, the transition to digital assessment has also brought along new challenges in terms of school equipment, although this is getting better, in terms of also ICT familiarity. And the digital mode is challenging the assessment of some of the competences, for instance, writing skills, and it's also challenging the comparability of our assessments. So we are putting a lot of effort in our mode effect studies in order to keep trends. And of course, the digital mode also poses problems and challenges that are of technical nature, for instance, security issues and data privacy issues. So next slide, please. One of the major opportunities of this transition to digital assessment has been the use of interactive items. So on this slide, you can see a sample of more common QTI interactions that we are using on a TAO system. For instance, you can see the choice interaction, also gap match, text reader, and you can also see that these interactions can be combined with images and multimedia, so you can upload videos, etc. But what I would like to focus on today is the technology enhanced items that are developed by using the PCI standard. So these innovative items help us to create more authentic assessments or context. And here on this slide, you can see the PCIs that we've developed for mathematics assessment. So we have very many items that we've developed for mathematics assessments, and this is only a small sample here. And we can regroup this PCIs, or we can use these PCIs in two ways. So first, we can use PCIs as a tool. For instance, you can see here a geometry tool, also a spreadsheet tool or solving equations tool. So the students use these tools to solve a problem, but then they answer or they give their answer on the side, either in an input box or drop-down menu. But we also have PCIs which are developed as a specific environment. So for instance, the area and perimeter PCI here, where students, this PCI requires students to use knowledge on area to partition a gridded shape into equal area parts. And we also have an example of a cube building PCI where students asked to identify and construct a solid with cubes using top, front, and side views. And it's important to note that whenever, we can go back, yes, thank you. It's important to note that when the PCI is used as a tool, then we always aim for a familiar tool use. So these items are designed so that they are similar to the tools that students are using in the classroom. So they don't need too much time to get acquainted with the tool during the assessment. So next slide, please. So we've developed also many PCIs in science. And in science as well, there are different ways of using this PCI. So these PCIs could be simulations of a scientific experiment. So students can test things, play around, gather data, and then use this data to tackle the problem. Or we've also developed specific environment, for instance, the PCI on the top left corner, which allows students to construct a electric circuit by dragging, dropping elements on a workspace or canvas and connecting these elements. So here the problem or the exercise is within this environment. And we collect the data about these actions that students are, or the manipulations that students are doing on the item. So the PCIs can be leveraged to enhance the assessment of traditional competencies, such as mathematics and science, but where they really stand out as a useful tool is in the assessments of so-called 21st century skills. So on the next slide, you can see two items that we've developed for the assessment of creativity and collaboration. On the left, you see a chatbot PCI, which was designed and developed in collaboration with researchers in social psychology, and that aims to assess collaboration, but also creativity. So in this item, student interacts with an avatar, and the task for the student is to create a story or to co-create a story in collaboration with this avatar. And avatar makes propositions, and then student either refuses or accept these propositions. The student needs to explain why. So this is the collaboration part. And then this item also has an interactive or additional interactivity where a student can select, for instance, location for the story or the characters, and can also enter text for the startings and the endings of the story. And this is only an extract of this item, so it takes a student around 30 minutes to go through the whole item. And then on the right-hand side, we have a text timer PCI. So this is a quite typical item to measure divergent thinking. So student needs to generate as many ideas as possible within a defined time limit. And we've collected data with these items pretty recently, so we are only starting to analyze this, and this is a new research field for us, and that has become possible to measure because of these PCIs. Now, of course, these PCIs are extremely valuable for assessing students' digital skills. So here on this slide, you can see a file explorer simulator on the left-hand side, which was developed to measure digital skills. And this is pretty similar to the existing file explorers of different operating systems, but it generalizes and simplifies them. So students have the usual functionality. They can look for files, they can navigate the files, visualize the content, they can search, they can also copy, paste, drag and drop, and they can preview some of the files, but there are no real applications connected to this item. And on the right-hand side, we have a programming SNAP PCI. So this was developed for measuring computational thinking. And SNAP is an open source block programming language that was developed by University of California, Berkeley. And that was encapsulated in a PCI. And namely, we needed to reduce its size because it was too heavy to run efficiently on our assessment platforms. Now, last but not least, we also take advantage of these technology enhanced items, or PCIs, to measure literacy and numeracy. So here we have a lexical decision PCI, which was developed to measure reading speed. So in this item, there's a series of stimuli that is presented to students, and then students have to respond as quickly as possible if the stimulus that is presented is an existing word or not. And they don't need to use those buttons. They don't need to click on the buttons to answer, but they can use the keyboard, which is of course more accurate to measure the speed. And on the right-hand side, there's a number line PCI, so developed for measuring numeracy, where students have the task to convert decimal numbers representation on a number line. And as you can see, both of them are designed in a game-like manner. So it's again to enhance the student motivation to respond to that type of assessments. And these items are developed to identify struggling students and to see how well they've integrated automated processing of some of their skills. So all of this PCIs produce very rich data. So potentially all the interaction, all the clicks, mouse movements can be recorded. And this rich data allows us to study not only the final response of the student, but also analyze how the student is processing or how the student is tackling the problem. So this type of process data analysis, we can just go back a little bit, thank you. This type of process data analysis is an emergent field of research in education. And we've also been analyzing this type of data at DEPP in order to distinguish different students' problem-solving strategies. So, of course, this type of information or analysis is very useful for teachers in the classroom because it's informing them on the cognitive processes of students. And I'm not going to go into detail of this analysis here because I don't have enough time. But I put down an article here that we've written with a couple of colleagues at DEPP. So if you're interested in learning more about that, then you can access this. So what we learned from working with this data is that in order to make valid interpretation and to make this data actionable in the field from an assessment for learning perspective, we really need to tighten the collaboration between three different aspects of our work. So these are technology. So this is item development and item software development. And we are looking into ways how to better standardize our log data collection because up to now, different vendors are using different ways of logging these items and recording the data. And that, of course, challenges the data processing and data analysis. Then, in order to make valid interpretations, we also are using a theory-driven approach. So we need to have valid hypothesis, valid research question. And this theory-driven approach also makes our interpretations more acceptable in the field. And of course, then we need to apply different analytical tools. And we've been applying machine learning algorithms to make sense of this data because the data is often messy and we need to look for ways of making sense and removing the noise from it. And then more recently, we've been using also UX methods to complete the log data coming from these items. So DEPP is an active member of the FLIP plus C assessment community that Mark mentioned. And this for us is an excellent space for sharing. So FLIP plus is all about sharing. We're sharing knowledge and experience. We're also sharing technology solutions and of course, content. So for instance, the items that I was showcasing you are open source and can potentially be shared within the community. And then we are launching a working group around process data. And this working group is also meant for sharing research methods, but also concrete tools and research findings. And this group is open to non-FLIP members. So if you're interested, please reach out to us at this email address that I put on the slides. So thank you everybody for your attention, and we are happy to answer your questions now.